over 16. Good. Next. What is to be done? Quickly, guys. Very good. A 5 is a factor of 15. 15 is a multiple of 5. What you do to cancel out? To cancel, you look for the highest common factor. Highest common factor for 5 and 15 is 5. 5 percent goes into 15. 15. Now we have x and x here. You can also cancel your x's, okay? If they say you have a xylophone and a xylophone, they both can cancel. X percent goes on to x1. Anything else to cancel? Very good. 4, that's right, you guys. 4 percent goes 1 into 16. 4 times. So the final answer is, everybody has that in your books? Awesome. 3 over 4. B says solve the inequality. Solve the inequality. The inequality is count of please. Minus 4m. Well, less than or equal to. Good. Bear in mind, we get quick history. I don't know if they should be start, I'm not sure you want to be classes. If I have 4 and 6, which is greater, 6. If I divide 6 by positive 2, and I divide 6 by positive 2, 4 divided by 2 is what? 6 divided by 2 is what? Good. So it still remains, inside remains the same. What about I have 4 is less than 6, but this is what I'm going to do now. I'm going to divide by negative 2. Let's give me 1. 4 divided by negative 2, guys. You guys will be shocked of the answer, you know. Very good. What would this answer require? 6 divided by negative 2. Negative 3. Nobody will make that. Which one is bigger? Negative 2. What happened to the side? It changed. Whenever you're dividing, matter of fact, that does divide. Whether you're dividing or multiplying by a negative number, the sign has to change. Let's practice with the multiplication now. Let's go. Let me see. Me try 2 different numbers. 5 and 7. Which is bigger? 7. See 7. Let's multiply 5 times 2 and 7 times 2. So 7 times 2. Like you see, 5 times 2. Which is bigger? Good. But look at this now. 5 is less than 7, but 5 times negative 2 and 7 times negative 2. 5 times negative 2 is what? This is the negative, which is bigger. So what have we discovered here? This is very crucial in inequality. This is what makes it inequalities. So without this, knowing this, inequalities can operate regularly and an equal sign in between them. But you must remember, if you're dividing or multiplying by if you're dividing or multiplying by a negative number, the sign has to change. I can even give you one with a negative on top. Because it's negative 4, negative 6. Negative 4 bigger than negative 6. If I divide by a negative, if I divide by the same negative 2, what's going to happen? It's going to give me what? Positive 2, it's going to give me what? Which is bigger? You realize that? The sign what? Change. Right? I could show you every other thing, but then I think I'll get you one. Right? So I think you can buy this. Okay. Good. So based on that, when you're dealing with your inequality, always remember that if you're going to divide or multiply by negative number, the sign will change. You have a choice. And somebody's writing, you have a choice to carry this or this. If we move this to be over here, and we move this to be over here. Likewise, we have this and we have this. Somebody tell me which is your choice. When you carry minus 4m to minus 8m, which will become 1. When you come over, you 1. Plus, good. But then what about if you bring this over? This will be 1. Which way do you think you should go to make sure that you have a positive number, a positive m? Okay, let's carry this over. I'm going to bring this over. Right? Let's go. So 12, A move. What came over? 5. So it will be what? 12? Take away 5. Good. And then this went over to be what? Positive 4. Good. 12 take away 5 is what? 7. Thank you. Negative 8 plus 4. Negative 4 m. Then we're going to divide both sides by what, class? We divide both sides by what, class? You want m. You want m. What did I divide it by? Baka na. But if I divide by negative 4, what is what happen? No, we can do the decimal now. We'll try it again. Because there's a fraction, but what is to happen? What did I show you a while ago with the ready? Guys, our memory are too sharp. 10 seconds ain't gone yet. I said I'm repeating it 3 times, hoping I write it down. But I mean, I don't know why to listen to pay attention. This side has to what? Change. Then 7, you put the minus side in front, and the whole fraction, and you put the m. Okay? That's one way. That's one way. I'm going to stop and there. Another way was, if you brought this over, it'll become positive am. That means you have positive am take away 4m. That means the m would have been positive. So this one now, this is what we're going to do. Instead, we're going to bring over the am, negative am, and we're going to carry over 12. Give me the equation, somebody. Plus 8m less than or equal to 5 take away 12. Good. 8 take away 4. 4m. Good. 5 take away 12. Good, so it'll be 7. And then m is less than or equal to negative 7 over 4. Now what the open is? You will change this side, right? Because I did not divide with a positive a negative number, I divided with what? Positive. If you don't do this, because somebody wants much little funny. I divided with a positive 4. What's that? So now left up with m less than or equal to minus 7 over 4. And negative and a positive is the opening of negative. When the opening is, the opening A facing the fraction. And look over here, the opening A facing the fraction. You realize? But why this sign here ain't change? When you divide by a positive, the sign don't change. But you get the same answer? Good, so I want to understand that. You get the same answer. So the only difference between an equation and an inequality is that you have to remember when you divide, that's not simple mean where you are. Divide or what? Multiply by a negative number, the sign what? Changes. Okay? Please, from today, don't forget that. Tell us that. Please do something. All is so comfortable. LR from if you think about it, if I take this, I'll come across in here. One here and here in the same length? Yes, right? Yes. That means if I'm going to show you in the matter. This and this is the same. So if this is x plus 3, and the whole thing is 3x, is correct. You simply do what? 3x what? Subtract. But here is the secret. Put a bracket. Watch this. If you don't put a bracket, look what happens. 3x minus x plus 3. What can happen? You don't subtract these two items. And left out the 3. We do here 2x plus 3, but that's not right. This is actually wrong. So the bracket helps us to do what? And the bracket helps us to do? The separate equation, Malika, very good. Malika, what is that? You're close. It's still missing something. You say something yesterday? I mean, this is divide. There's a law that has loops in it. What the law is? Big with D. What do people do when they give to the poor? They do what? They do what? They distribute. They want the distributive law. If you do it this way, the minus is attached to the first thing. We will the tree, it's not the tree, right? But if you do it this way, and treat as a negative one, what happens now? What happens now, class? Very good. The negative one is now distributed over all elements in the bracket. See? So this is the fourth element in here. So negative 2 here. It is still there. You understand? The negative one will be distributed to all the what? The elements on the inside of the bracket. Good. So now it's not just the first thing getting touched. Everything in the bracket will get touched now. It's called a distributive law. Good. Which gives me what now? Negative x still, but this will be what? Negative. Huh? This is a 1, you know? Huh? 4. When you do this, what operation are you doing? So negative 1 then is negative x. Negative 1 then positive 3 is what? Negative 1. 3. Good. Now you get what? What's the answer? Guys, why are you pausing on these simple small numbers? Say to me please. 2x minus 3. Guys, this is frightening, you know. Even second form is what we do. This is second form work. But it is second form. Right? So very good, Yel and Malik and whoever else, recognizing that this line and this line is the same. And so if you take x plus 3 and the whole thing is 3x, you take away this one, and the whole thing you get that with you. So what goes here is 2x minus 3. You got that? We'll move this now. And the same thing with R cube. What's the full thing? Now, again, you don't have this already. So you take away that from that. But I forgot to write down something for this. I want to give you the, remember the one with you. I want to give you M, N, take away, L, R, give you PQ. And over here, LR, LM, that's not LM, what else? Finish out what I put this. I just showed all you. LM minus PN, thank you, Matty, equals what we're looking for, R2. Good. What is LM? What is PN? So put x plus 1 here. Thank you. Whenever you have a minus sign, be very careful. And again, why we put the minus sign? Why you tell me? Why are we putting the minus sign? The brackets are in. You get a wrong answer because if you leave it like this, you may say 4x minus x, but this you may choose a positive one, but really that minus 1 makes that plus 1 negative 1. What's that? So I give you the equation quickly now, guys. Quickly, you over the time. Give me the equation. 4x, huh? 5, Good. Rearrange. Or you have to rearrange this. Move them. 4x minus x. 3x minus 5 minus 1. Huh? Then I do 6. Then you have to say nothing. So we have A and B. We add A plus B. We say A plus B equals that. We work it out. What's this? Like you have the 4 part, but A or 4, you tell me, it is 432 equals 0. Then you want this to look like this. What do you do? Make a suggestion. What are we doing to get this to look like that? What do you do? Very good. Well, okay, I start with factor here. Yes, yes. Right, come on, factor, very good. And come back to be 6. The divide all of the terms by what? 6. So, good. So this to this goes what? Then you said you do? Yes. Good. And 0 divided by 6 is 0. So, CXC give you the answer. CXC gave you the answer. I tell you, find the answer. And as you can do it. Alright, so we did the next times with of A, 3x minus 6, x plus 3. Give you all of that. The FOIL method, first outer, inner, last. Start with the capital. The other one is the distributive block. With that. Combine together, so the total is this. The bracket was unnecessary, as I explained. I want to show you because when you have an addition sign, the bracket is unnecessary. You simply put them together, you group them as many always reminders, then you form, and then you say, 6 to 0 you all of them, bam, 6 walking up together. Alright? So, what new we learn from this? What new thing we learn from this? What is that, huh? Is it Jordan? What we learn new from this, guys? Quickly, what do you think you? Okay, what was reinforced in this? What concept have we saw in this then? We said?
Foil.
We have grouping, we had foil. What's on the inner line, the distributive law. Remember, foil is a form of distributive law as well. Okay? So distributive law, first of the inner line is foil. What about this? This is a compound shape where we recognize that if m to n is 3x, and you have x plus 3 L to R to bring across here, then you take away L from mn, which gives us as the from QP or PQ, whatever you want to call it, okay? So fine. So we form PQ and we form R. Okay, good. So when you see the power of 2, what does it mean? You write something what? Twice based on one operation. Multiplication. Remember, when you if I tell you to write x cubed 2 times this is simply saying 2x cubed. But if I say x cubed and a square up here, this is saying x cubed, let me think of it, let me do it. It's saying x cubed by x cubed. But really, x cubed by x cubed is really this, x times x times x times x times x times x. How much x we multiply here? X to the 6. So a shortcut would have been 3 plus 3 is what? 6. And another shortcut would have been 3 times 3. Very good. Whenever you see a power within a power, you multiply into powers. Let's make up one then. Let's make up one for fun. Let's make up one for fun. X to the 4th power to Q. What will be the shortcut? Very good. Which gives you x to the 12. But the other way would have been what? X to the 4th times x to the 4th times x to the 4th times x to the 4th. Or 3. Right. Thank you, thank you at the bar. I'll be funny too. Let's go. Okay. So we got, well, what we done on here? Yeah, before we put it 12, what we put? What is this example, guys? Let's follow pattern. 4 plus 4 plus 4, which is x to the 12. And if I expand this even further, I'm saying x times x times x times x, that's 4, right? Then the next 4, x times x times x times x, remember multiplication between them. And x times x times x times x. How much x I have here? Let's go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now clearly, this is the waste of time. That's too long. That's the real reason. No? This is still too long. Let's simply do that. Okay, about that? Good. And then I told you that before, but let's get a little history in case it comes in a different way. Alright. Then we have y8 divided by y to the negative 5. Y to the 8 divided by y to the negative 5. I want to explain something here about this negative sign. So I have y cubed divided by y squared. Watch this, right? I'm going to write it two different ways. If you can understand, y cubed divided by y squared. That's the same thing, right? If you're multiplying, what do you do to the powers? So we're dividing, we subtract. So 3 minus 2 give me y1, which is simply what? Y. Good. Look at this now. Y divided y times y times y over y times y. What can that mean? Go back, then again, go back. Leave me with what? Y over 1. Or what? Y over 1, which is 1. Yeah, the same. Good. Now look at this now. I'm going to switch it around. I'm going to put y squared divided by y cubed. Very good. So y squared on top and y cubed to the bottom. Good. What's here now? 2 take away 3, which divide everybody. The next thing we're going to say will be what? Negative 1. But watch this one now. Y times y over y times y times y. So the order is going to be different.
Okay, what's
Question 3. Good. Some people project this and come back. Let's go. Y cancel y. Y cancel y. But what happening here now? What's the answer? No, cancel that y. This was y over 1.
So it's 1 over y.
1
Negative 1
over 1. The negative 1 over 1. No. This is just simply 1 over y. So what is it telling you? If you use this method, you end up with a negative 1. 1. But if you use this method, you end up with 1 over y. But R is different? No. So when it is positive, you get the same exact thing. When it's a negative power, we end up with that. What do you call this shape? What do you call that in math? A fraction or rational number. Rational or factor statement. So what I'm telling you there, that's why when you have this, take it to 0, take it to 1, take it to 2. Watch this now. Take it to negative 1, take it to negative 2. What normally happens here? Take it to 0 is what? 1. And the power of 1 is itself. You say 10 times 10, which is what? 100. But look at this one now. This is actually what? 1 over 10. And this is really 1 over 100. And this is actually 0.1 10 backwards. And this is what? 0.100 backwards. See that? But the point of this is to tell you that anything which has a negative power is a fraction. But that? Take down that quickly, guys. Anything with a negative power is a fraction. And note this, as you're writing, a 1 is here. You know, 1 is here, right? So that negative 1 is really now already as 1. Positive 1. 1. Everybody understand? Good. So, as you're writing, I'll give one example. So end with d to the negative 3. Another way of writing the negative 3 is what? 1 over d cubed. Remember that? Just read that. So then t to the negative 4 is what? What tell me? 1 over 1. T to the positive 4. Good, very good, very good. Remember that? So remember that, please. Anything that has a negative power is actually written as a fraction, and the power now becomes what? Positive. Everybody have that? Come on, answer the question again. This is the question. Is it part easy? Yeah. Okay, so let's be this one of them. No, you sure? Oh, I take the picture of the phone. You're good, man. You're good. Guys, so this divide means what? Why do the powers? So subtract, right? So what's this? 8 take away negative 5. Which really is 8 plus 5. Which gives you y equals 13. So you see you pass out 3, but really is what? You know, this does not know. You need that one to report this one. Yes, you guys do looking at this. Balance. X minus 1 on the y, okay? So that's the answer. So really, in fact, the highest common factor is y. Think about it like this. If I give this, I give 6, take away 8. 6 is what? 2 times 3, right? And this is what? 2 times 4, right? I'm going to say 2 times 2 times 2. Let's do that. Put up on this point factor. Right? What's common to both sides? The 2, right? Yeah. Good. So you take out the 2. One leave back here. One guys, 3. I want to leave back here. 2 times 1. Which is what? Let's back check on the distributive now. 2 times 3 is what? 2 times negative 4. Negative 8. Come on.
Yes.
Okay. So if there was that, so the highest common factor in this case is what? 2. So the highest common factor in this case is 1. Huh?
Wait, no?
No, wait, come on. No, another one, I need another easy one after. This is the telecom for 450. What's up with telecom? Okay, good. Now what does this look like to you? and need to have a name. And what the video that did that, you should know the name. This looks like something. Close. What give me another name for this here. Give me another name for this. Subtract. Give me a word that you use to know you got the minus. Another one. Difference. Continue now. Difference of 2 squares. Very good. Let that for me, please, stick it out and please. This is an example of difference of 2 squares. This is sharp difference. I want the full word, please. Alright. How do you find the difference of 2 squares? I'll try it. Hold them there. I love this. You can't be running there. Don't take all them. Alright, come back here. Guys, different 2 squares start like this. But remember, do that for me, please. 1 square here, 1 square here. What's happening here? You ask the question, what, when you place it here and you square, give you x squared. X. What you put in here, you square it. What? So then, you are basically finished. X minus y. And it could be x plus 1, x minus 1. Anyone who go first. This could have gone, Jahid. Oh, we laugh in Ben Junior. So we report that in Ben Junior, we laugh too. So by laughing, you know, we all of us will laugh together. And see who does. Wait, give me the camera.
No, you're gonna laugh and say, but it's your bad.
Happy.
Stop it now.
Let's go. So next down, number 2 says hence, simplify what? The expression. So they give you this now. They give you x, y minus y squared over x squared minus y squared. Now we done work up this already. We done work up the top. Yeah. So x minus y, and down here is what? Let's put x plus y, x minus. When they put the x minus y there, so tell me. Very good. So you can easily show like they were the what? They cancel each other. Very good. Leave him up with what class? Good. And guys, nobody cancel that y and that y. Why that y and that y can't cancel? Different expressions, very good, yeah? No. Yeah, but also because it's a plus. They can only cancel when you have what? Watch. If I had this, by watching, can the y's cancel now? Yes. The y's cancel because of multiplication sign here. So the only sign you cancel with is what? The multiplication sign. If you have plus, nobody get a point idea. Somebody get a boy guy in the top about, you can't be the one, stick with the one, then shut up. So, let me just stop it. And listen, the difference between those two is what? The difference between M and N is 64 centimeters squared. Good. Good. So they say the distance of the areas. So how we find the areas for this? Let's go. What's the area for M? Oh, okay. I'm sorry, let me put this one first. Sorry, wait a minute. 3x plus 4 times x minus 3. You see that? Then minus, that is n. X plus 2, x minus 3. Let me see, yeah, give me all of these. Let's go. 4. Good. 3x squared. It's 3x squared. Minus what? Okay, these two together. Yes, so minus 9x. Plus 4x. I see it. No. Minus negative or positive. Minus. Yeah, he was fine. We used it kind of. I think because doing this was over here and that was over here. Yeah, that's the problem. Well, I realize this package is serve the purpose, isn't it? No, so we said we would get this package is serve the purpose. Let's go. This package is serve the purpose. Somebody else. Maddie? You take this one. Foil. Okay, Jenny. Yes, Jenny, let's go. X1. Anybody? X squared. The man just comes up, you know. Negative 3x. Plus 2x minus 6. This bracket serves a purpose. Good. So what this will be is 3x squared minus x plus 4x minus 12. Then negative and a positive. Negative
1.
Negative x Class, let's go. Hello, watch this, what I'm doing? Guys, negative and negative is guys, we had this all class now. Whenever you multiply by negative, what will be the size in here? So what will be here? What will be here now? 2x
Plus 6.
I'm sleeping in here though. Joel, let's go. You know what? Joel, you next. Fix those two. Okay, I'm confused now. Let's go. These two. Huh? 3, take away 1. We have 4 of these now. This. So negative 9 plus 4. Then negative 9 plus 4. Yes, sir, obviously. Take on the name.
It's negative 5.
Negative 5x. Good, hold on. Negative 5x plus 3x.
Plus 3x.
Boy, look.
Negative 2.
Negative 2x. Negative 2x. Negative 2x. Thank you. Minus 12 plus 6. Negative 6. They said all of this equals, well, when the subtract equals what? 64. What's next? So 2x squared minus 4x minus 6 minus 64 equals, what does this give you? Negative. Hey guys, we're not done. You can get calculator some nice kisses. Kiss the calculator. Stay in our life. This look like this? So how can we get this to look like this? What? It will be what? It will be by what's that? 2 divided by 2. 1 over 1, which is x squared left back. 2 to the 4 goes to the negative 2 left back. And 2 to 17 goes 35, or half of 17 is 35. So this gives us x squared minus 2x minus 35 equals 0.
Seven?
Yeah.